So, hello everyone. First of all, I want to say thank you to Manuel and to Apply Machine Learning Days to welcome me here. I'm very happy to be here in Lausanne and to visit the city. I'm working at the University of Paris-Saclay at the Listen Laboratory, and also I'm supervised by Anne-Laure Ligoza and Tom Bauer, which is at the Arts Métiers school, engineering school. And I will talk about my research topic, which is the digital e-waste and how to model the environmental impact. And actually, what are the facts? Well, I will say just the quick main facts about the topics. And first of all, I will define what is a digital e-waste. Waste is basically something that we discard, that the user discard without the intent of reuse. So it can have different treatment, and basically all the e-waste from digital are hazardous. They are harmful for the environment and for the human health if they are not properly managed. So there is a big deal to how to properly manage them in our country, and because we have the infrastructure. But I will show later that most of them are not properly managed. And because it's hazardous, they have a specific legal status, and they have been banned for exportation in the EU since 1989, and 199 countries signed the Basel Convention. And as we show with Xavier, IA is really material. It requires terminal, data center, network, infrastructure. And for all those materials, you have a life cycle chain, and it has impact from the first stage, extraction of material, to the last stage, the end of life for the disposal. And at each step of the life cycle, you have the pollution through the water, through the air, through the soil. It's really impactful. And each device have different lifetime. And it's really something we have to take care about. How long we want to make the material, how long we want to use it, for how to conceive it, and so on. At a global level, this number has been released last week. 62 billion of kilograms of e-waste have been produced in 2022, and only 20% of them are properly collected and recycled at a global level. And 78% of them don't go through formal recycling. It's informal waste. And I will show also later what can be the path for e-waste. And as we saw also earlier, the impact of ICT is constantly growing, and it's the same for the waste. More we produce, more we use IT, more we will generate e-waste. So it's something that we have to think about, how we want the future and how to take care of this e-waste. And now I talk about the number of e-waste, but not all of them are from digital. And to collect and to treat the e-waste, the EU has created categories. And here there are only 6 of them, because we have number for 6, but there are 7 categories today. And only one category of e-waste is 100% ICT equipment, the number 6. And after you have, for example, laptop in the category 2, screen and monitors. So you have different equipment in different category, depending on how they collect and how they have to be treated after. And here is a schema with a percentage of France. In this schema, you can see what can happen to e-waste at its end of life. And on the left side, you have the formal collection and the formal treatment, and on the right side, you have the informal treatment. So for France, 53% of the e-waste is properly collected. And on those 53%, 3/4 of them are properly recycled. So they're going to have mechanical and chemical treatment, and we're going to recover maybe 10 or maximum 10 or 15 material from the recycling, and to produce digital equipment, it's about 70 material. So we recover very few material from the recycling. And after recycling, you have the energy recovery. And from the energy recovery, in France, it's about 12%. And so we put the e-waste into big incineration, and we're going to recover the heat and the energy from incineration. And then after that, the next treatment is elimination, either with landfilling or with incineration without recovery. Maybe landfilling is one of the worst treatment, because it can release toxic substance to the environment. And the last treatment in France, less than 2% of the equipment is reused. So we're gonna collect either component, or we're gonna do treatment in order to reuse the equipment. For now, it's maybe one of the preferred treatment, but it's the one who happens the less. And on the informal treatment, you have the metal waste, then you have the house waste, and then 10% of them are illegally exported. So this is the part I'm focused on my PhD, what happens to the e-waste if they are illegally exported, mostly in Asia and then in Africa. We try to see what percentage is it, and what are the treatments you have after informal collection, with informal recycling, informal incineration, and informal landfilling. And something which is also quite important to notice, like it's really common, because e-waste is banned for exploitation. One of the things is, okay, we can donate equipment for reuse, and after, when it's sent legally, most of the equipment is in fact e-waste. So this is a common practice, and it represents 4% of the e-waste in France. So I work in the modeling of the environmental impacts, and as I can quickly say that most of them are underestimated, and it's also an invisibilization of impact because of the use of the substitution. And if you have to remember something, like most of the impact for digital waste are the human toxicity and the ecotoxicity. So I will not enter into this, but this is a way of informal recycling with all the leak of toxic substance in the environment. So I will finish with this schema. The best way to reduce e-waste is to not produce it. So we have to think about this is the only way.